Uh, our organization's based out of Santa Fe, New Mexico, where we draw a lot of inspiration from the Santa Fe Institute and Los Alamos National Laboratories. Our work is grounded in complexity science. So, we favor adaptable, emergent, and scalable systems over rigid and brittle architectures. We focus on enabling users to form dynamic groups and roles to enable fluid interactivity. And philosophically, we believe that the browser is the OS and focus our development on browser-based technologies. The four that I'll be talking loosely about today include Live Texture, which is our platform for reality capture from cameras and geospatial contexts. Any Surface, which is our interactive surface platform that leverages camera projector pairs to create interactive, in our case, sand tables. AgentScript, which is our agent-based modeling library, all based in JavaScript. And lastly, the Asakia, which is our decentralized compute storage platform, all being browser-based. So we couple these technologies in a variety of different configurations to empower our products. Those being the Simtable, which is our AR sand table for geospatial phenomena that includes aspects of any surface, AgentScript, and loosely Asakia. And Realtime Earth, our platform for collective intelligence, which uses live texture and the Asakia. So, which I'll primarily be discussing today. So we use these products to help communicate and explore and help people understand what we consider geosocial phenomena, with our work primarily being in the wild and fire space. We consider wild and fire to be one of these geosocial issues where we have environmental problems that overlap with social issues at geospatial scales. Wildfire is a very complicated problem due to a myriad of issue or factors that include, climate change, land mismanagement, and disparate data points. But this problem cascades into a variety of other problems that include timely and effective evacuation, post-fire flooding due to vegetation loss and increased soil hydrophobicity, and evolving mitigation strategies, including prescribed fire, home hardening, and landscape design. So, unfortunately, we are effectively fighting blind when it comes to wild and fire incidents. Take, for instance, this example, the Camp Fire of 2018. The fire started near the town of Polga, right where that yellow star is, up in the top right corner, around 6:45 a.m. And within 6 hours, the town of Paradise was nearly entirely consumed. The fire was moving at a rate of roughly 1 football field a second. And with delayed reports of fire and a lack of coordination, circumstances like the following arose.
Paradise Police, how can I help you?
Are we supposed to be evacuated or what?
No, you'll be notified. There's a fire north of Concal, up off of Highway 70. No danger to Paradise, okay?
Well, it says evacuation west side of Pence Road.
What says that?
Butte, fire.
Okay. Okay, we haven't been advised of that. If you have gotten a phone call, or if you see flames or feel the need to leave, then do that at this time. But we haven't been notified, okay?
Yeah, so, more and more catastrophic events like the Camp Fire, the Lahaina Fire in Hawaii, and more recently, the LA fires are occurring with significant structure damage and considerable loss of life. But as you can hear, there was some valuable information that the citizen had that the dispatcher couldn't quite make use of. So we feel the need to bridge that gap between citizens and emergency responders. And to that end, we ask ourselves, how can we prove intelligence during the first 3 hours of an incident?
Wow.
So, real-time data streams relevant to wild and fire diversifying. You have these publicly accessible camera networks such as Alert Wildfire and Alert California are great, but they're only controllable by camera operators and designated officials who have credentials. So they're not, necessarily truly accessible to communities abroad. But with the ubiquity of cell phones and people feeling the need to document instances like wild and fire, we see the potential for an array of imagery being generated when leveraged collectively from citizens, crews, and social media. This can be the largest sense array available to first responders and the community in peril. And the fusion of these outlets is what we feel is essential for situation awareness. But we take the different perspective in that we recognize there is a difference between collecting intelligence versus collective intelligence, right? So this idea of like surveillance versus surveillance, the need for bottom up, where Sue's sort of originating from, is where we feel there's a lot of power. So the need for this common operating picture is not nearly as useful as many relevant operating pictures for the individuals who need it. So not anybody needs to know every single thing going on, not even the incident commander, but everyone should have their own relevant understanding of the relevant understanding and situational awareness. So to accomplish this, we are developing Real-Time Earth, a browser-based platform for collective intelligence. Data silos are all too common in the emergency management space, and in many cases can be a disservice to both emergency responders and civilian communities. So in our case, we feel Asakia allows us to push data to the edge and provide the capacity for increased data sovereignty by leveraging a decentralized architecture, dynamic group formation, and maximizing the privacy of our users. So the Asakia in tandem with live texture is what we feel will are what are empowering our geospatial tooling that is in this instance, or in our current instance, leveraging Cesium, that allows our users to calibrate imagery, derive data from this imagery, and disseminate information. So in this particular talk, I'll be focusing on one aspect of our live texture platform that we built into Cesium that we call projective texturing. Our tools comprise a variety of different modules, but the one I'm focusing on today here is projective textures. And the idea behind projective textures is this idea of projection of calibrated imagery. So you can kind of see here on the right, I have a little frustum of a cell phone that has taken a picture from up above this scene here. And the texture of that image is being projected out onto the three-dimensional model. In this case here, a model of the Santa Fe rail yards. But really what this now empowers us to do is geospatially contextualize imagery with respect to 3D tiles. You can kind of think of this as a slide projector or a flashlight with a transparency on the front that I'm shining about the room. And we find it most powerful when it's interactive. So it's great that it provides our users feedback when they're fitting imagery, when we are performing an event reconstruction, having multiple of these projective textures interacting with each other, and the data that we can derive from some of the consensus that we see between these images. Now, we've done this before. We've been working on Real-Time Earth for a while, and originally we built our own globe inside of Three.js. This is a camera that captured the Adams Fire, which was a small fire north of Reno, Nevada, that wasn't big enough to hit the national scene, and it wasn't a crazy huge fire, but it's very impactful to the region itself. But from this camera perspective, we have an infrared view of the progression of the fire, and with projective textures, we can visualize that adjacent to the progression of the fire. As you can see, this sort of yellow to red gradient of where the current state of the fire is located, the black line already identified by previous imagery, and the route that the dozer is taking and its current status along that route in the cyan color. So we're very familiar with the technology to empower this and the algorithms needed and the shaders needed to be developed to empower this. So bringing it into Cesium, we recognize that there are a lot more constraints. We don't have the freedom that we have in Three.js, in the sense that, one, we don't have direct access to the shaders. Cesium has a lot of stuff to offer us. So we figured, okay, we can probably find a workaround for that. Entities and primitives are not very useful when it comes to dynamic positioning. And, but at the end of the day, we really wanted to avoid forking Cesium as well. We didn't want to have our own custom build that was reliant on constantly updating a Cesium base code. So with these restrictions and after a couple attempts, we settled on using the post-processing stage feature inside of Cesium. This allows us to make render passes on the view uh, after the main rendering cycle. And we can do multiple passes. So this empowers us to be able to do multiple projective textures in the same frame. And all this is really being done by a custom fragment shader. So a rough outline of how this works: you have the base Cesium render that runs through its cycle, and it produces a color texture and some depth textures. These, alongside the view camera matrix, are input into the post-processing stage, along with, from our side, the image that we're looking to create a projective texture from, a depth texture, and the projective textures matrices that are defined by the camera matrix of where that image is the pose is being held at. And all those come together inside the post-processing stage to render the final view. So maybe a better visual of how that works: imagine we have this context here on the left, which is our viewer camera. So this is the main view that Cesium's rendering, and this is its color context. And what we're trying to do is that white dot there in the middle, we're trying to render the projective textures that would align, or that would end up in that particular pixel. So we then use the depth textures that were created from the rendering cycle to get a world coordinate that we would then use as a reference point for the projective textures in the following steps. And this depth position, this world coordinate, and the viewer camera matrices are used to reproject that screen coordinate into the world coordinate, or into the coordinate space of the depth of the projective texture camera. So now that we have this world coordinate, we go back to the viewer camera, since we know where that is located, and determining its relationship to the projective texture, we can basically determine whether or not, given the projective texture camera here on the right, and the reprojection, we can determine whether or not that point is located within the UV space of the camera. And in the case that it is located within the camera, we know that we can then basically modify the pixels in the viewer camera's coordinate space if we need to. And if it's outside of the UV space of the projective texture camera, we can go ahead and discard it. So at this point, we know whether or not we need to project a particular pixel into the viewer camera's color texture. We can go ahead and sample the UV space from the projective texture camera, and then add that, one final determination needs to be made whether or not we have some form of occlusion. So a particular world coordinate can be within the UV space of the camera. However, if we know that, given the depth of the projective texture, that world coordinate is in the same spot, or is within view of in this case here, the green mountain we're showing, and it is then confirmed to be visible from the projective texture, and we can project that. However, if the world coordinate depth that we see in this case on the right side, the orange mountain, is much further than the depth texture received from the projective texture camera, and then we can assume that that particular point is not visible, and we can avoid applying our projective texture to that point onto the landscape. Or otherwise, you can basically say it's in the shadow of, if we're trying to project onto the orange mountain. So that's loosely how projective texturing works and how we implement it in Cesium. And to see it in practice, this is a view of our Cesium renderer looking at the quarry fire from last year in Colorado. This is an image from AirOps that is capturing a thermal image of the fire location early on during the fire. And with projective textures, you can kind of see here, looking at it relative to the 3D tiles generated from Google, we can actually identify like literally what trees are being lit up by the heat signature. You know, some of them these are all likely on fire. The darker ones may have burned already or will likely be catching fire soon. Later on, I think the following day, we have another render or another image from a citizen or a crew member. And from this perspective, when it's calibrated and projected, we can see that we don't see a lot of flames on that ridge that's closest, but we can see a lot of projected texture flames on the second ridge. So it's most likely we can confirm that that ridge in the middle where we're seeing no projection is where those flames are at. And then lastly here, we have a hand-drawn map that was a photo was snapped of. Our image calibration tool lets us calibrate maps like this, which is a whole nother talk, but we'll likely give that some other day. But with this being used as a projective texture, we can now see all three of those projective textures being used in tandem and see how the fire progressed over time and some of the potential future operations that the first responders want to do in this particular instance. So in conclusion, we feel that collective intelligence has the potential to solve the dilemma of the first 3 hours of a wildland fire using existing resources and decentralized computation. In regards to more features that we're working on in real-time Earth, we would like to annotate imagery to generate GIS, which we've done in our 3GS system before. We just need to port it to Cesium. Also, live streaming projective textures. So not just imagery itself, but what if you had more dynamic imagery like videos or live streams, which again, we've done before in 3JS, but need to bring to Cesium. And then lastly, when we think about the Acequia, perhaps maybe in some future, we can have a self-hosted Acequia ion node that can be pumping in more 3D tiles and GLTFs and whatnot. So with that, I'll take any questions and thanks so much for listening.
Cool.
Very cool.
That'd be nice to then cut that out, right? And just get this nice 15-minute talk, right?
Definitely.
And then put that up on YouTube or Leaflet or on LinkedIn.
Yeah, no, definitely.
That was a great one. That was great. Great application of the infrared and being able to, yeah, that was great. I think that was compelling.
What was that
Very
like?
very professional slide design too.
Yeah,
Thank you.
you're good at that. Mr. Aesthetic, I know.
It's half of a presentation.
It's beautiful. Comes well. It's well received.
What was the response like at the conference?
Pretty good. I think time-wise, I only really had time for 2 questions before they had to move on to the next speaker. But the question that came in was pretty good. It was more on the technical side of Cesium, like, hey, I'm trying to do the same exact thing, but these are issues that I'm running into. And I kind of talked a little more about that we run into the same issues when we deal with small scale stuff versus large scale stuff. We can do projective texturing over large swaths of land pretty easy, but it's the small micro like projective textures on the buildings that we're having a lot more artifacting in, and just sort of recognize that we both have the same problem. And then another question came about that was like, this is great for wildland fire, but what are the other applications and how have your users responded to this? And so it was a nice kind of more broad question that I was able to kind of navigate with our diversifying user base and dealing with clients like in Austria that have never seen wildland fire before and they don't have even models for it, and how can we use this tool to help them facilitate generating new models and that kind of stuff. So and then afterwards I got a lot of there was a little meet and greet little party thing that I got stopped a couple of times of people that were there, and we're just like, it's so cool, we don't know anything about wildfire, but and then the tech is great, but they're very intrigued by the monitoring aspect. It's like, oh, can you look at in this case, one girl was working on flooding, and it's very much like, how can we apply this to flooding? And so it was good. It was good overall. I think most people that were there were interested, and yeah, so it was a good time.
Very good.
It was
So
a breakout session. How many people were in that session? Sometimes those can be kind of sparse.
are you talking about the lightning talks?
Yeah, was this a lightning talk?
No, no, this wasn't a full session. So and actually it was wild. I got, because there were a lot of cancellations, I think because of flights actually, I got pushed ahead 2 hours. So instead of being that last talk before lunch, I was the first one in the morning. So I think it kind of helped get more people there, which was cool. But yeah, and they recorded it. They said they'll be posting it sometime on YouTube in the next couple of months, but we can certainly beat them to the punch.
Oh, I see. Uh-huh.
Yeah.
Uh,
It'll be like the professional Cesium recording books.
yeah, so I've seen other people post their slides, so that's an option too.
Yeah,
And
totally.
and then wait for the talk. And it's just
Yeah,
enough to really on our network to at Cesium at Patrick, and then he tends to comment and promote it to his network, right?
totally.
Was
Totally.
were you able to talk with Patrick or other Cesium folk?
I talked with a couple of Cesium folks that were a little more on the dev side. There was different lanyard colors. So if you had a maroon lanyard, you were a Cesium employee. And so I tried to chat with some of them. And a lot of their stuff was, they're interested in what we were doing in regards to, they have layer draping, but it's very much a raster that's top down and
Mm-hmm.
not obliques. And so that is what garnered a lot of interest, was this how are you projecting obliques out, and there's a lot of kind of conversation on that front. Not too much on acequia. I mean, granted, it wasn't on the forefront of the talk, so there wasn't as much interest on that, but definitely the projective texture and the wild and fire stuff. So there's a lady from the University of Miami who was interested in using what we're doing, but with oil spills and oil spill recovery. So,
Mm-hmm.
and there was another gentleman who was actually doing uh, depth map lidar scans panospheres. That was we talked a little bit about what we were doing. We kind of just got on a tangent, and that's what that person was doing. And I talked about what we were doing with Allure Wildfire, and there was a lot of
Was
interest.
that Aerial Sphere out of Scottsdale?
No, no, it was a city in Germany that
Oh,
commissioned
okay.
a lidar reconstruction of their town. So there's a lot of, we had a good conversation with them. And then there was another recent grad, but in the flooding space, that was really interested in post fire flooding and how that works. But they're like in the they're on the East Coast, so it's like it's not really a post-fire flooding part, it's just the flooding part. So
Mm-hmm.
good conversation there. And then the developers was primarily about the ortho, or the what do you call it? The oblique projective texturing that